Hello, third VTech EC students. Good morning to all of you. This is Industrial Electronics subject, Unit 5. You already delivered one lecture. This is the second lecture. We are discussing about applications of ultrasonic waves. Ultrasonic waves are widespread industrial applications. Okay. In the last class, of course, we have discussed how to generate ultrasonic waves. That is using mainly piezoelectric effect. We can generate ultrasonic waves from 20 kHz to 50 megahertz. So these ultrasonic waves have a lot of applications, widespread applications in industry. Okay, number one is ultrasonic flaw detector in industry. Flaw detector is nothing but it detects the defect in the material. Number two, ultrasonics in study of structure of matter. So we can study the structure of matter. Number three, ultrasonic waves in communication. Number four, ultrasonics in distance measurement. Number five, ultrasonic cleaning. Number six, ultrasonic medical applications. Number seven, ultrasonics in water industry. Okay, purification of water. These ultrasonics are UV RO systems are there nowadays. They are used. Ultrasonics for removal of microparticles in industrial fumes. Number 9, ultrasonic soldering. Number 10, ultrasonic cold welding. Number 11, separation of mixtures by ultrasonics. Separation of mixtures by ultrasonics. Number 12, degassing of liquids by ultrasonics. Number 13, ultrasonic drying. Number 14, physiochemical effects of ultrasonics. Number 15, chemical effects of ultrasonics. Number 16, thermal effects of ultrasonics. Number 17, biological effects of ultrasonics. Of course, there is the number 18 also, ultrasonic stroboscope. Okay, so these are the lot of applications are there in industry. So we'll discuss one by one. Number one is ultrasonic flaw detector. Okay, mostly the ultrasonics flaw detector most commonly used in industry. The flaw detector is nothing but detecting defect in the material. Okay, so ultrasonic waves are widely used in non-destructive testing. Non-destructive testing of material. Non-destructive means without disturbing or without destructing the material or metal or product, we can find out whether it is defective or not by passing ultrasound through that. Okay, this is what you call ultrasonic flaw detector, non-destructive testing. Okay, ultrasonic waves are widely used in non-destructive testing (NDT) of metal and concrete products. The strength of material depends on its homogeneity. Okay, strength of material depends on its homogeneity, the structure. If the material has some defects, such as flaws, the strength is reduced. Strength of the material is reduced. Okay, so material inside there are defects, the strength will be low. So we do not know what are the defects. That we can find out by using ultrasonic waves. Ultrasound. The flaws in the material can be detected by using ultrasonic waves. Okay. Ultrasonic waves propagate in homogeneous solid in a straight line and get reflected from boundaries of the material. The boundary is the air or from the flaw in the material. If there is a flaw in the material, it reflects from the flaw. Okay. So when ultrasound propagate in straight lines, and these ultrasound can be reflected. If there is no defect in the material, it goes up to end and it is reflected from the bottom. If there is a defect in the material, it is reflected from the defect point. So we can find out where is the defect, depth. Okay, this property is utilized in flaw detection. There is what we call pulsed echo ultrasonic flaw detector. Pulsed echo. We send a pulse and we get a reflection. Reflection is called echo. Pulsed echo ultrasonic flaw detector. So you can see the diagram. There's a CRO, transmitter, receiver. There is oscillator pulse and there is a receiver also, transmitter cum receiver. That is connected to the job under test through the piezoelectric crystal. Okay, because this transmitted pulse goes to piezoelectric crystal, then ultrasonic wave is produced from that, and that ultrasound is sent to the job under test. There is a material under test. Okay, if there is no defect in the material, the ultrasound goes up to bottom and gets reflected. That is case A. It takes time T1. If there is a defect on the right side, if you can see in job under test, if there is a defect, a flaw, it gets reflected from that defect point. That is the case B, where it takes less time T2. So assume that flaw is at a distance of D, at a depth of D. So total depth of the material is L, but flaw is at a depth of D. Okay, it takes less time. Okay, A is reflected pulse from bottom, B is reflected pulse from flaw. Okay, so as you can see, the CRO, there is a transmitted pulse. Okay, so immediately if there is a defect, we get what we call pulse B. There is the echo at a time of T2. So if there is no defect, we get pulse A at a time of T1. So that clearly you can see on the CRO whether defect is there or not. Okay, that's how this pulsed echo ultrasonic flaw detector works. Okay, so here the piezoelectric crystal acts as a transducer. Piezoelectric crystal acts as a transducer. Okay, we are sending a pulse that is converted into ultrasound and sent into the material. If there is no defect, we get pulse A. It goes full length, full depth. Takes time T1. If there is a defect or flaw, it goes up to depth D, case B. So the echo returns back within short time of T2. So that you can see on the CRO. That's how it works. Okay. From the CRO, we can find out very quickly whether there is a defect in the material or not. Okay. If there is no defect, we get pulse A. If there is a defect, we get pulse B. That's why we can test number of materials very quickly using this pulsed echo ultrasonic flaw detector. Okay, it is very easy to test. There is a mechanism for sliding this piezoelectric crystal, because you have to test the whole area where defect is there. Okay, so probably defect may be there anywhere in the material. Okay, so that's why completely we have to scan. We have to completely scan the. So we have to move the crystal, piezoelectric is on the top of the top surface of the material, so that ultrasound goes into all parts of this material. that is job under test, so that we can completely detect the material is perfectly alright or if there is any flaw or defect in the material. Okay, that is how it works. Okay, ultrasonic flaw detector. Ultrasonic flaw detector. Please note down this diagram if you have not already taken, because already I have sent notes. In the notes also this diagram is there. Here the diagram is given very clearly. Okay, the CRO video is shown here, transmitted pulse BA T2 T1. Okay, that I think will give how it works. Okay, this is next. So this figure shows the block diagram of ultrasonic flaw detector, UFD. Block diagram of UFD. Okay. Operation. Piezoelectric transducer, when excited by transmitter, the operation of this piezoelectric transducer, when excited by transmitter, it transmits ultrasonic waves in short pulses into job under test. Transmitted pulses are reflected from bottom as shown in case A and reflected from flaw as shown in case B. Okay? Transmitted pulses are reflected from bottom as shown in case A. There is no defect. It is case A, reflected from bottom. If there is a flaw, they are reflected from flaw in case B. The reflected pulses, they are called echoes. The reflected pulses, they are called echoes, are received by receiver. Out of two pulses A and B received, T2 by T1 is equal to d by V by L by V, where V is velocity. D is the depth of the flaw, L is total depth of the material. So T2 by T1 is equal to D by L, where D is depth of the flaw is L into T2 by T1, where L is height of the job under test, T2 is time taken from the flaw, T1 is time taken from the bottom. T2 and T1 are measured, of course, from CRO. You can find out from CRO. Okay, connected to the receiver. CRO is connected to the receiver. Okay, thus the depth of flaw can be located. This method is called reflection method of flaw detection. There are, of course, various other methods of flaw detection. This is one of the popular methods. This method is called reflection method of flaw detection. Okay, here we can find out the depth of the flaw, depth of where it is located. Okay, that is equal to L into T2 by T1. And the point where it is defect is also, position also can be located, depth also can be located. So both can be located. We can identify this the position and depth of the defect in the material, and we can reject that material. For example, we have to test large number of materials, okay, hundreds of materials, whether they are suitable or not. Then we can reject based on this flaw or defect. We can put in the rejection this thing. So if there is no flaw, we can send this to the for setting into the unit or whatever it may be, this material where it is used. So we can set that. Now we can say this is okay. Okay, tested okay. Okay, this material is stamped with tested okay, and If it is of defect, of course it is defect. We put a stamp defect and put somewhere separately. Okay. That's how this reflection method of flaw detector works. Okay. Then number 2, ultrasonics in study of structure of matter. Ultrasonics in study of structure of matter. Ultrasonic waves are used in the analysis of structure of matter. We want to analyze by observing velocity of ultrasonic waves in the matter, in the material, and the effect of frequency and temperature on the velocity, the information about certain characteristics of the material such as concentration, coefficient, compressibility, and compressibility of matter can be obtained. So ultrasonic frequency is used for this is 1 to 20 megahertz, very high frequency. So ultrasonic waves are used in the analysis of structure of matter by observing velocity of ultrasonic waves in the material and effect of frequency and temperature on the velocity, the information about certain characteristics of the material such as concentration, coefficient, compressibility of the matter can be obtained. Okay? Ultrasonic wave frequencies used are 1 to 20 megahertz. So is a very high frequency. Number 3, ultrasonic waves in communication. Ultrasonic waves can be focused into beam, just like electromagnetic waves, and transmitted over long distances. Ultrasonic waves can be focused into beam and transmitted over long distances. It can be used in sound signaling. Okay? It can be used in sound signaling. Ultrasonic waves can be used for signaling between submarines also, okay, for communication purpose. So this is what you call sound signaling. Okay, we'll discuss about this one separately on sound signal. Ultrasonic waves can be focused into beam and transmitted over long distances. It can be used in sound signaling. Ultrasonic waves can be used for signaling between submarines. Number 4, ultrasonics in distance measurement. Ultrasonic waves can be used for finding depth of sea. Okay? Ultrasonic waves can be used for finding depth of sea, distance between ships or submarines, etc., particularly in the water. Okay? Ultrasonic waves can be used for finding out the distance, vertical distance, like depth of sea, and also distance between, horizontal distance between ships and submarines, etc. Okay? This distance can be measured using ultrasound. Okay? Where electromagnetic waves cannot be used, the ultrasound system works very well, particularly in water, for submarines and for ships, etc. So ultrasonics in distance measurement, that is called also called as sound signaling in water, is very much used. Okay, ultrasound in water. So we have a lot of applications of the ultrasound for distance measurement on earth as well as in water, etc. Because particularly in water, it gives very accurate, because where there is no alternative, we have to use ultrasound only, ultrasonic waves only, for finding depth of sea or distance between two ships and communication between two ships, and also signaling. So many other parameters can be detected using ultrasonics. Okay. Then we have ultrasonic cleaning. Fifth application is ultrasonic cleaning. Ultrasonics can be used to clean the object from dust. Any object or any part can be cleaned from dust, grease, oil and other impurities. Okay. The objects to be cleaned are kept in steel containers with chemical solution. The objects to be cleaned are kept in steel containers with chemical solution like trichloroethylene. Okay, the objects to be cleaned are kept in steel containers with chemical solution like trichloroethylene. Ultrasonic waves are passed through this solution using piezoelectric transducers. Okay, ultrasonic waves are passed through this solution using piezoelectric transducers. Contaminated articles can be cleaned by irradiating ultrasonic waves. If there is a contamination on articles, okay, which can be cleaned very easily by ultrasonic waves. Okay. Due to ultrasonics, the solution is agitated. Bubbles ranging from microscopic to large size are created. When bubbles collapse, high pressure waves are produced, resulting turbulence in the solution. Therefore, the solution is accelerated and cleaning is done. Okay? So, due to ultrasonic waves entering the solution is agitated, bubbles ranging from microscopic to large size are created. When bubbles collapse, high pressure waves are produced, resulting turbulence in solution. Therefore, the solution is accelerated and cleaning is done. That's how the ultrasonic cleaning, some of the objects, some of the materials, some of the even nuts, small materials can be cleaned using ultrasonic waves. Okay. Then we have very important this thing is ultrasonics in medical applications of ultrasonics. Okay. Ultrasonics are used in surgery, therapy and diagnosis. Ultrasonics are used in surgery. Surgery means you know it. Okay. Therapy means for treatment, and diagnosis for finding out what is the problem. Okay. Three important this thing. Ultrasound is used for diagnosis to find out what is the defect. That is enlargement of heart, enlargement of kidneys, enlargement of liver, okay, or fatty liver or something like that. We can diagnose first what is the problem. It is used for treatment also, therapy, okay. It is also used for surgery purpose. Ultrasound is used in surgery also, okay. Three important departments of medical field. Okay, diagnosis, therapy, and surgery. Okay, first diagnose what is the problem we can find out, and next what is the treatment for that. There also we can use ultrasonics. Then in surgery also, it is ultrasonics is used in many applications. Number 2, highly focused ultrasonics is used in neurosurgery. Okay, particularly surgery in the brain. Neurosurgery is surgery in the brain. They are highly focused ultrasonic beams. Ultrasonic beams are used in neurosurgery. Okay, particularly for treating tumors and some other blood clots in the brain. The ultrasonic waves are used, that is in neurosurgery. Okay, very important one. And the other applications in the medical field, ultrasonic radiation is used for examination of soft tissues and for treatment of soft tissues. Ultrasonic irradiation is used for examination of soft tissues and for treatment of soft tissues. We can find out the tissue, soft tissues, like tissues in the lungs, tissues in the, for example, esophagus, and tissues in the stomach, like that. And also for treatment purpose also ultrasonics is used. Okay. For number 4, ultrasonics diagnosis provides information about position and extent of characteristics. Ultrasonics diagnosis provides information about position and extent of characteristics. So ultrasonic diagnosis is very important now in the medical field. So we can use for a number of applications. As you can see now, 5th application, ultrasound scanning. Many of you know it. What is ultrasound scanning? Is used to find out the baby position in the womb. Okay? And also, what is the problem? What is the position of baby? Ultrasound scanning. It is also used to find out true picture of kidneys. Where kidneys are enlarged or normal size, we can find out. And we can find out cervix, cancer cells are there or something like that. We can find out similarly uterus. We can find out bladder. Okay, is normal or expanded. We can similarly liver. Okay, we can find out fatty liver also. Similarly spleen, whether it is expanded or normal or infected, something like that. Pancreas also, whether it is infected or normal. You can find out heart, it is enlarged or any problem in the heart. Okay, and you can find out prostate size and any problem within organ. Okay, prostate, another. And so most of the inner organs of the body, human body, can be detected, can be diagnosed. Okay, immediately we can find out what is the problem. Okay, and not only problem with the organ, problem within the organ also sometimes you can find out using ultrasound scanning. That is very important. Almost leave alone industry in the medical field. Ultrasound scanning has revolutionized the diagnosis procedure. So otherwise, the internal organs of the body were unable to detect what is the problem unless they open it. Okay, without damaging, without opening. Okay, we are non-destructive testing. Okay, testing of the inner parts of human body. That is a really wonderful application of ultrasonics. Number 7, ultrasonics used in water industry. Probably is also very important because ultrasonic waves in the water industry, ultrasound is used in level measurement, where water level, and also flow measurement. Okay, what is the flow? Ultrasonics are also used in disinfection. Okay, to kill the bacteria infection. Okay, but normally this RO system, there is ultra UV RO systems are there, where there is nothing but ultrasonic waves are passed through the water, so the bacteria is killed. Decontamination, disinfection, decontamination, dewatering, and degassing, there is more oxidation, and dispersion are showing highest potential to high intensity ultrasound. Okay, so a lot of applications are there ultrasonic waves in water industry. High intensity, high frequency ultrasound can get high killing rates of bacteria and destruction of microorganism pollutants. Okay, if water is polluted with bacteria and microorganisms, the ultrasonic waves, high intensity, high frequency ultrasound waves are used to kill the bacteria and also destruct microorganisms. So this is also very important application of ultrasonics. I think this second lecture will close here. Thank you very much.